Okay, there's several ways to simplify this algebraic expression involving radicals. We're going to use these two properties. If you have the square root of a divided by the square root of b, that's the same as the square root of the fraction a over b. And notice that in this expression, b has to be greater than 0 because you can't take the square root of a negative number. And you can't divide by 0, so it's got to be greater than 0. And the other property, the square root of a times the square root of b is the same as the square root of the product. Okay, there's several ways to do this problem. This is the way that I would do it. I would combine these two radicals and put them under one radical and then make the fraction as simple as possible. So there's the 4 in the numerator. There's the radical of the fraction. If you reduce that fraction, 8/20 reduces to 2/5 by dividing numerator and denominator by 4. And x cubed over x to the 5th gives you two extra factors of x in the denominator. And you can take the square root of this x squared. So that comes outside the radical. 4 over x times the square root of 2/5. You can write that as, you can break the square root of 2/5 into the square root of 2 over the square root of 5. Why am I doing that? Because I'm going to rationalize the denominator here by multiplying numerator and denominator by the square root of 5. And if I do that, in the numerator, the new numerator will become 4 square root of 10. Radical 2 times radical 5 is radical 10 over radical 5 times radical 5 is 5. So I've just rationalized the denominator. That is, there's no radical in the denominator. And this little rectangle right here from Desmos shows you that the original expression, although I used an a instead of an x, and this expression have the same decimal equivalent. And if you go to Desmos and use this slider on a, you'll see that these two decimal evaluations are always the same. So those two algebraic expressions have identical values. I've set a starting at 1. You could have a number less than 1 but greater than 0. And here's another way to do the problem. I'm not sure I would ever do it this way, but you could simplify each of these radicals by breaking it apart. So 8 is the square root of 4 times the square root of 2. X cubed is the square root of x squared times the square root of x. I'm going to break it apart like this because you can take the square root of the x squared. It's got an even exponent. And in the denominator, 20 is the square root of 4 times the square root of 5. X to the 5th, square root of x to the 4th times the square root of x. These cancel. These cancel. The square root of x squared is x. The square root of x to the 4th is x squared. So I've got 4 radical 2 times, well, one of these factors of x now cancels out, x radical 5. If you go through the same process I did here of rationalizing that denominator, you get the same thing. Okay, so there's a couple ways to do it. There's other ways. You just have to do what's most comfortable for you. Okay, there you go. Hope that helped. If you have any questions, post a comment.